Okay, so our next topic is gas laws. We're going to just go over some general information about gases. So gases are everywhere. So in the air you're breathing, there's nitrogen, oxygen, water vapor, other gases. And we also know from the beginning of the year that gases uniformly take the shape of any container. They're easily compressed and mix with other gases. So pressure. So pressure in terms of gases, okay, is really just collisions. So gases will exert a pressure on their surroundings, and we measure this with a barometer. And pressure is defined as the first force per unit area on a surface. So usually you'll see like on, like on a tire, we'll say PSI, pounds per square inch. But for gases, basically when the particles collide with the walls of a container, they exert a force on that container. So they're making a pressure. So the more collisions you make is going to mean you're going to have a higher pressure. So these are just some examples of barometers, tire pressure gauge. All right, so pressure units for gases. So in chemistry, we have gas in many different units. So there's atmospheres, pascals, torrs, mmHg, psi. We won't use psi too much in this class. We'll use the first four mainly. And for pascals, we really are going to use kilopascals. So this is a torr, this is millimeters of mercury, and 1 atmosphere. Atmospheres are abbreviated ATM. So you've kind of maybe seen these numbers in some practice problems I've done, but I haven't really explained what those numbers mean. So all of these pressures I just gave you are equivalent. Right now in this room, you are at 1 atmosphere pressure, which is also 101.3 kPas, which is also 760 torr, which is 760 mmHg, which is 14.7 psi. So those are all equivalent. So, back to conversion. So, how do we convert? All right, so all of those numbers you just wrote down, okay? We're going to use them to convert. So remember, you write down what I give you, times, make yourself a fraction. The number for kPa was 101.3. I'm trying to cancel out kPa, they have to go across from each other. 1 atmosphere, the number, that one with ATM was 1. Then you're going to do 234.8 divided by 101.3. Which is going to be 2.32 atmospheres. So, just reminder about how to convert 834 millimeters of mercury to psi. So again, start with what I give you, times. I'm trying to get rid of mmHg, that needs to go in the denominator. I'm trying to get to psi, that goes in the numerator. The number in that equivalency that I gave you next to mmHg is 760. The number next to psi is 14.7. So I'm going to do 834 times 14.7. I get 12259.8. I need to divide that by 760. I get 16.13 psi. Try the last one on your own and then check it with what I'm going to write on the screen. So I have 213 torr times, trying to get rid of torr, that goes in the denominator. kPa goes in the numerator, that's what I'm trying to get to. The number that was next to torr is 760. The number that was next to kPa is 101.3. So I do 213 times 101.3, which is 21576.9. Divide that by 760. We get 28.39 kPa. So we are going to be having to do pressure conversions in this unit. So this is something we've been practicing all year. We did it in stoichiometry. We did it in the mole. We've been doing metric conversion. So this is something that's just going to keep coming back. All right, temperatures of gases. So we have 3 temperature scales. Fahrenheit, Celsius, and Kelvin. Fahrenheit is what I call the F word of chemistry. Not going to use it. We will never use it in this class. Most of the time we use Celsius. For gases, however, you must use Kelvin. So there is no other temperature you can use when you're doing any math with a gas. So any math calculations we're going to do, we're always going to be using the Kelvin temperature scale, which is based on what's something called absolute zero. So notice the Kelvin scale starts at 0 and goes up. Celsius, the 0 is kind of in the middle, but the actual degree amounts for Kelvin and Celsius are the same. So the actual 1 degree of Celsius is the same amount of heat as 1 Kelvin. And Kelvin we don't call it a degree, we just say Kelvin. All right, so this is the conversion, so make sure you have that. So to get any Celsius temperature to Kelvin, you're just gonna add 273, that's it. Now, absolute zero is the temperature on the Kelvin scale where all motion ceases. So scientists have not yet gotten to absolute zero. So this is just kind of theoretically, they think that all motion ceases. They don't exactly know what that means, but they've gotten pretty close, I think, within a millionth of a degree. So they've, slowed down those molecules, because remember, temperature is not a measurement of heat. It is the average kinetic energy. So it's how fast particles are moving. And just like I said in the slide before, when you do anything with gas laws, you must use the Kelvin scale. Nothing else will work. You cannot do the calculations in Celsius. They must be in Kelvin. That's why that Kelvin equals degrees Celsius plus 273 is going to be so important. All right, so let's do some converting. I want to get from Celsius to Kelvin, so I do 34 plus 273. That's all I have to do. It's that easy. I get 307 Kelvin. All right, try the next one. 254 Celsius to Kelvin. Add 273. Which is 527. 0 degrees Celsius to Kelvin. 0 plus 273. Can't get much easier than that. 273 Kelvin. Now I want to do the reverse. Kelvin to Celsius, I'm going to subtract 273. Negative 60 degrees Celsius. And it's okay to have a negative temperature in Celsius, but you will never have a negative number on the Kelvin scale, and that's the reason we use it for gas laws, because we can't talk about a negative pressure and a negative volume. That's not a thing. Another important concept is the concept of standard temperature and pressure. So measurements for gases can be calculated at something called standard temperature and pressure, which is STP. So standard temperature is 0 degrees Celsius and 273 Kelvin. Standard pressure are all those numbers I wrote there. So just make sure you have that down, because that's something you need to memorize. What is at STP? So just know it's those temperatures and those pressures.